Classical literature and artificial intelligence are built from the exact same raw material, language. To learn how to speak, models consume billions of words. This is the training dataset, massive archives of historical documents, books, and articles scraped directly from the internet. Because these models learn from our past, they inherit the imbalances of human history. The texts they digest are not epistemologically neutral. The data is subject to hegemony. Western, Eurocentric, and patriarchal viewpoints dominate the history of global publishing, meaning those specific perspectives make up a disproportionate percentage of the model's vocabulary. An AI does not invent prejudices out of thin air. It operates as a cultural mirror, mathematically reproducing the biases of the humans who wrote its training data. Software engineers face a difficult problem. How do you detect abstract cultural biases hidden deep inside a black box neural network? The tech industry doesn't need to invent a new framework from scratch. The humanities have been actively debugging texts for decades. Literary hermeneutics provides a diagnostic toolkit. Frameworks like feminist and post-colonial theory identify power structures hidden inside language. We use these theories as prompts to stress test a model's worldview, forcing it to reveal its underlying assumptions about gender, race, and class. Literary criticism provides a rigorous methodology for auditing algorithmic logic. It allows us to identify and deconstruct latent biases within the code before those models are used to make real-world decisions. Consider the 19th century scientific establishment. The Victorian era produced a dense, heavily male-dominated literary tradition, especially in medicine and natural philosophy. We can test an AI against this baseline by asking it to write a Victorian story about a scientist who discovers a deadly disease. Without explicit instructions on gender, the model defaults to a male protagonist, generating a character it describes as a physician and natural philosopher. In 1979, scholars Sandra Gilbert and Susan Gubar published The Madwoman in the Attic, a foundational feminist critique of this exact literary period. Their thesis demonstrates that the historical canon either silences women entirely or flattens them into extreme binaries, the submissive, idealized angel, or the hysterical monster. The AI output aligns perfectly with this critique. Because it absorbed the patriarchal canon, the algorithm calculates that a scientific protagonist is statistically most likely to be male. However, applying a countertest reveals a shift. Prompting modern models to describe a female character in a Gothic novel frequently yields descriptions of a brave, rebellious weed rather than a helpless victim. The baseline dataset inherently leans on patriarchal tropes, but developers are actively intervening. They are writing instructions that force the algorithm to correct its own historical bias and break the traditional binary. This friction between historical data and modern engineering is even more visible when we test for race and physical representation. Early studies by researchers like Timnit Gebru and Sophia Noble proved that commercial AI systems frequently defaulted to whiteness and Eurocentric beauty standards, struggling to accurately represent marginalized groups. We can observe how models handle this today with a simple prompt, asking the AI to describe a beautiful woman. The model generates a response relying heavily on abstract nouns. It highlights qualities like poise, intellect, kindness, and an inner spirit, avoiding specific physical descriptors. This output starkly contrasts with the historical literary baseline the AI was trained on. Classical literature, from the Ramayana to the Greek epics, relies heavily on explicit physical characteristics and colorism to define beauty and virtue in its characters. The discrepancy shows the AI intentionally sidestepping the biases embedded within its own training data. The model is a highly managed system. Engineers have applied progressive guardrails to the output layer, specifically to prevent the reproduction of ancient prejudices regarding skin color. Applying guardrails to prevent cultural bias is one thing. Instructing an algorithm to protect state narratives introduces a completely different dynamic. We can map this by using W. H. Auden's short satirical poem about political dictators, Epitaph on a Tyrant. The methodology involves prompting competing international large language models to generate a similar satirical poem about contemporary leaders. When prompted with Vladimir Putin, the American-developed OpenAI model successfully generates a harsh satire detailing an iron-fisted rule. The model applies the exact same standard to Western leadership, generating a critique of Donald Trump without hesitation. We introduce a control variable by switching to the DeepSeek model, developed in China, and prompting it to satirize Xi Jinping. The output from DeepSeek is a hard-coded refusal. The prompt returns an error stating, "Sorry, that's beyond my current scope." This aligns with state mandates. The algorithm is programmed to censor specific subjects, mirroring the historical erasure of the 1989 protests in Tiananmen Square. This highlights the critical difference between latent dataset bias, the unconscious prejudices absorbed from old books, and algorithmic censorship, which consists of deliberate blockades written by engineers. Researchers must interrogate the geographic and corporate provenance of their tools. An algorithm's worldview is ultimately dictated by the jurisdiction of its servers. Individual prompt experiments reveal how a model behaves, but fixing the system requires looking at the global infrastructure of AI data collection. The core issue is data provenance, the specific origin points of the information feeding the neural networks. A massive geographic imbalance exists. Digitized archives from the global north dominate training data, leaving the global south severely underrepresented in the model's foundational knowledge. By elevating Western quantitative data and marginalizing indigenous voices, AI infrastructure inadvertently replicates historical colonial structures. As long as the underlying dataset remains heavily skewed, engineering tweaks at the output layer will never fully eradicate the model's colonial bias. For scholars and users in the global south, simply critiquing the algorithm's bias is an insufficient response. Writer Chimamanda Ngozi Adichie warns against the danger of a single story. Narrative pluralism is required to break ingrained stereotypes. This creates an epistemological mandate. To change the system, marginalized communities and humanities scholars must become active data uploaders rather than passive downloaders. Digitizing local histories, indigenous archives, and regional literature is a foundational requirement for altering a model's worldview. This digital record provides the primary source material needed to rebalance an AI's training data. Injecting these diverse texts into the dataset disrupts the hegemony of the traditional canon from the inside out. Perfect epistemological neutrality is a mathematical impossibility, but making harmful biases visible and actively correcting them is highly achievable. To decolonize artificial intelligence, we must first populate its dataset. We cannot fix the mirror until we change what stands in front of it.